All right, now we're going to move into graphing sine and cosine functions. We're going to take all the information we have learned up to this point and kind of put these onto a graph. We're going to convert from going around a circle to, well, you'll see what it comes out to be. So what we're going to do now is we are going to take, remember how we knew that before we looked at the x, y as cosine and sine. Okay, now that's up to this point. Now what we want to do now is graph just the sine function on an xy axis and see what that looks like. So here's the function we're talking about. F of theta equals sine theta. So sine theta is going to be the, whatever you get for sine theta is going to be the y. Theta is going to be the x. You know how it's like f of x equals whatever. So say it's sine of x. We're just replacing x with theta. All right, so the x is the angle. So this is the x. And the sine of x, the sine of theta, sine of the angle, is going to be the y on our graph. Again, the x-axis is going to be the angle measures, and the y-axis is going to be the sine. We are not graphing cosine. We're not going around the unit circle. This is different from that. Okay? So get that cosine x sine y thing out of your head. We're not doing that type of graph. We're not going around the circle. We're just doing the sine functions and saying, okay, what happens when we do sine of 0, sine of 30, sine of 45? And we're going to graph that. So we already know these, though. We already know sine is 0. Just go take your unit circle. If you have a unit circle with you, you'll get these right from that. Okay, so the sine of 0 is 0. That's the y value on the unit circle. Okay, the sine of 30 is 1/2, so that's 0.5. We're going to do decimal form. It's going to be easier to graph when they're decimals. Okay, sine of 45 is radical 2 over 2. That's 0.7, approximately. Sine of 60 is radical 3 over 2, and we know that's 0.866, so we'll call it 0.87. Okay, sine of 90 is 1. That's the y value, right? When you go up, 90 is up, the y value is 1. And then we're going to go back down to 120, so it goes back down to 0.87. Sine of 135 is 0.7 because it's radical 2 over 2. The sine of 150 is 1/2, so it's 0.5. And the sine of 180 goes back down to 0. So now, again, that's just taken right from your unit circle and then just converting them to decimals, like radical 3 divided by 2, 1 divided by 2, okay? So we already know those. Now, let's write these as coordinates, x, y, okay? And then we're going to plot these points on our graph. So this is 0, 0. Okay, remember, x, y. So these top ones are your x's. These middle row here is your y. The next one is 30, comma, 0.5. Okay, then it's 45, comma, 0.7. Then it's 60, comma, 0.8. I'll just leave the 7. I don't have room. This one's going to be 90, 1. Okay, then it's going to be 120, 0.8, 135.7. Okay, so on and so forth. 150, I know you can't see that well, 0.5. 180, 0. 180, 0. Okay, let's continue. 210. Now it's negative because we're in the third quadrant now. Sine is negative. Negative 0.5. Negative 0.7. Negative 0.8, negative 1, negative 0.8, negative 0.7, negative 0.5. Where am I getting these from? I am getting these from the unit circle. Okay, and then back to 0. Why? 0 and 360 are the exact same thing, so obviously the sign would still be 0. That's just going around the unit circle, grabbing those y values. Y values. The sine, right? We're graphing just sine. It's the y values all the way around the unit circle. Okay, so you have your unit circle with you. That'd be very helpful. All right, so you guys can fill this in now. I don't want to waste time in the video. Just go ahead and do that. 210, comma, 210, comma, negative 0.5. I can't even really fit it in here. It's just too small. All right, so we're going to plot these points on this graph right here. So I can set the graph up for you. All right. So I'm going to just go up a little bit here. I just need these points. These are the points we're going to plot, okay, on this graph. So we're going to scale the y. You could scale the x-axis and y-axis however you want. I already scaled the x for you, so you just got to scale the y-axis. Let's make the 1 up here. Let's make the top line 1, and let's make this 0.5. What am I doing? 0.5. This middle line here is going to be 0.5. This will be negative 0.5. And this will be negative 1. So we're going to plot now these points. So 0, 0, bam, right there. 30.5. Now, this is 90. So in the middle of 0 and 90 is 45. So 30 is like right here, and then 0.5 is like right here. So right about there. 45.7, we said this is 45, and then 0.7 is like, this is 0.75, so 0.7 is like right there. 60.8, 60, and then 0.8. Just a little, yeah, that's too high, that's too high. Just a little bit above 0.75. And then 91, 91. So there it is. So we got this curve right here. See that? See how that works? We got that nice little curve right there. Okay, let's keep going. 120.8. Now 120's 30, just a little bit. This is 150 here. I'm sorry, this is 135 here. So 120 is a little bit to the left of that, and then it's 0.8. So that's going to be right here, right there. 135.7. 135.7 is right there. 150.5, 150.5 is right there, and 180.0 is right there. So see how it went up, and then it comes back down. Okay, and then keep going. So 210, negative 0.5, 210, negative 0.5 is right there. 225, negative 0.7. 225 is right there. Negative 0.7 is right there. 240, negative 0.8 is right there. And then 270, negative 1. So look what happens. It curves down. It curves down to negative 1. And then let's go back to 360. So it's going to be, boom, 300, negative 0.8. This is where are we at here? This is 3. Yeah, this is 315. Okay, whew, I messed up there. Okay, this is 315. So 300 is a little bit to the left. Negative 0.8, right about there. 315, negative 0.7. Negative 0.7 is right about there. 330, negative 0.5. is right there, and then 360 is 0. So as you can see, what happens is when we graph this sine function, as we go around that unit circle, 0 to 360, that's what we just did, 0 to 360. When you unravel that and just graph the sine, this is what the sine function does. Why? Because the sine increases, then it decreases, and then it increases, it decreases, and then it increases again back to 360. Okay, we're going to talk more about this and make the connection with the unit circle in class. Now, we're back to 360. So what's going to happen now? Well, since we're at 360, this is just going to repeat, because now you're going, after 360, it goes to 390, right? 30-degree reference angle. Right, so then it'll go 390, then it'll go 405, and it's just going to keep going and keep going and keep going. Well, 390, okay, let's think about what that is again. Here's 360, right? That's right here. 390 is just 30 degrees more, okay? So that's going to have the same sine value as 30 did. So whatever 30 was right here is going to be 390. Well, that was 0.5 right there. So you see what's going to happen. It's just going to repeat again. It's going to go around that circle again. So it's going to go boom, and then 90 is going to be the same as 450. And then 180 is going to be the same as 540. And then 270 is going to be the same as 630. Why? Because you're just adding 360. Remember coterminal angles? For example, if you take 630 and you take away 360, take away a full rotation, you have 270. So 630 and 270 are going to have the exact same sine ratio. They're going to have the same cosine ratio. All right, boom, boom, boom. And then 720 is the same as 360. Boom. So there it is. And it just repeats. It comes down, and then it goes there, and then it goes there. It creates this wave-like graph. Wave. Okay? So that's, and again, all we did was graph the sine functions, the sine of each angle, sine of 30, sine of 45, sine of 60. We just graphed all those, and it created this, okay? So we pretty much did this whole front page here, and I don't want to go too much further on the video. I just want to make sure we did all this. So we're going to answer some questions here. Extend the graph to 720. We just did that, so we already did this. So this is on graph. So let's use our graph to answer some questions here. For the interval negative 180 to 720, so for the interval negative 180 from here to 720, describe the values of theta at which the sine function has a relative maxima and relative minima. Remember relative max and relative min? It's the highest and the lowest point. Okay, so the highest point is at, theta is at 450, so max is 450, and the min is at, boom, 270 and 630. 270 and 630. Okay, does that make sense? The two lowest points, boom, right there, right? Negative 1's the lowest, 1's the highest. Where does it occur? Where does it occur? It occurs at 270 and 630 for the min. All right, for the interval negative 180 to 720, describe the, negative 180. I messed that up. Negative 180. That's way over here. So we got to extend this. I didn't do that. Sorry about that. Ooh, so we're missing, there's another minimum. There's another minimum at negative 90. And negative 90. And there's another maximum right here at 90. Okay, I messed that up. Sorry about that. So 450 and 90 are the maximums, and then minimums are 270, 630, and negative 90. Okay. For the interval negative 180 to 270, describe the values of theta in which the sine function is increasing and decreasing. So it's increasing. It's increasing. Okay, well, it's increasing from here to here. So from here to here, from negative 90 to 90. Okay, so from negative 90 to 90, it's increasing. It's also increasing from 270 to 450. Okay, and it's decreasing. Okay, boom, and then it's also increasing from, there's another increasing interval from 630 to 720. From 630 to 720, it's also increasing. Boom, right there. It's decreasing. Okay, it's decreasing. Let's do decreasing in red. Nice Christmas colors, right? Decreasing from negative 180 to negative 90. Negative 180 to negative 90. It's also decreasing from 90 to 270. It's just where the function's going down, right? Down slope. And it's also decreasing from 450 to 630. 450 to 630. All right. Couple more here. For the interval, list the values of theta at which the graph crosses the horizontal axis. So it crosses the x-axis. Boom, boom. Where does it? I'm going to do it in black. Okay. Right here, right here, right here, right here, right here, and right here. So those are all my zeros. Okay, so where does that occur? We're just going to list them out. Negative 180. 0, 180, 360, 540, 720. Those are all my zeros. That's where the function hits 0. Describe the end behavior of the sine function. Okay. Well, there is no end behavior because it's going to just keep going on forever. Okay. So as x approaches negative infinity, y goes between, y is in the interval, y goes between -1 to 1, -1 to 1, okay? So y is in the interval -1 to 1. And as x goes to infinity, same thing, y is -1 to 1. All right, so we're not going to really have to worry about end behavior for this too much. And describe how the sine function repeats. So what does it do? The sine function just keeps going, it keeps fluctuating between -1 and 1, -1 and 1. Okay, so what we're going to do is I'm going to have you have the sine done. You're going to do the exact same thing we just did here in class. You're going to do cosine though, okay? So back to the table tomorrow. In class, you are going to fill in your cosine table. How do you get it? Well, you're going to do the x values from the unit circle. What's the cosine of 0? What's the cosine of 30? What's the cosine of 45? You're going to fill all those in, and then you're going to plot those points and make a cosine graph. We're going to compare the sine graph to the cosine graph, and we're going to go a lot further with this. This is just the basics of our trig graphs, okay? So I'll see you then.